The question we are solving now belongs to test series 8. It is of control system subject. In specific, it belongs to frequency response analysis using Bode plots. This is a linked answer question. As per the question, the Bode magnitude plot of a control system is as shown in the figure. The Bode magnitude plot has a magnitude of 20 dB from 0.1 to 10 radians per second, and from 10 radians per second to omega 1, the Bode magnitude plots increases in a linear fashion with a slope of 20 dB per decade, and at omega 1 it reaches a value of 26 dB, and from 20 dB per decade on, the Bode magnitude plot decays with a slope of minus 20 radians per second. Sorry, at a slope of minus 20 dB per decade. So from the plot given, there are three angular frequencies that we don't know of. That is, one is omega 2, and third one, first one is omega 1, second one is omega 2, and the third one is omega 3. As per the question, we need to find the angular frequencies omega 1, omega 2, and omega 3 in radians per second. From the given plot, we see that as omega is varied between 10 and omega 1 radians per second, the slope of the plot is 20 dB per decade. So this can be written as S is equal to 20 is equal to 26 minus 20 divided by log omega 1 minus log 10. This is due to the reason that this straight line has a slope of 20 dB per decade, and it is joining the points log 10, 20 and log omega 1, 26. From this we got this equation, and upon simplifying this we get that omega 1 is equal to 20 radians per second. Similarly, as omega is varied between omega 1 and omega 2, that is corresponding to the region marked, the slope of the line is minus 20 dB per decade, and it is a line joining the points log omega 1, 26 and log omega 2, 20. So from this we can say that the slope is equal to 20 minus 26 divided by log omega 2 minus log omega 1. And upon simplification we see that omega 2 is equal to 40 radians per second. Now finally we see that as omega is varied between omega 2 and omega 3, the slope of the line is minus 20 dB per decade, and we are discussing now about the region marked. And in this region the straight line is joining log omega 2 20 and log omega 3, 0, and this should be equal to 0, 0 minus 20 divided by log omega 3 minus log omega 2. And upon simplifying this, we see that omega 3 is equal to 400 radians per second. So from this we see that from the given Bode plot, the angular frequencies that are marked are 20 radians per second, 40 radians per second, and 400 radians per second. Hence the correct option which gives you an idea about these angular frequencies is A.